All right, guys, on page 44, we find a new type of problem called a sex linkage problem. Before we can understand exactly how sex linkage problems work, I want to take a closer look at what we mean by sex linkage. We have to take a quick view of what we mean when we say draw an X chromosome or draw a Y chromosome. An X chromosome is nice and big like that, whereas a Y chromosome actually doesn't look like a Y at all. Instead, it looks a lot like an X chromosome, except that there's a section that is missing. So when we think of a sex-linked gene, I want us to imagine that gene being right there. And if something is going to be dominant or recessive, it will be like an R or a big R or a little r attached to the X chromosome. So we would expect to see a legend that would look like an X with a big R might be red, and an X with a little r would be white. So those R's are kind of like an exponent. So let's get rid of that and know that we're dealing with a legend that will have an X with a big letter and an X with a little letter. There's our legend. Peter's maternal grandmother, page 44, question 3. Peter's maternal grandmother had normal color vision. From a previous question, we would have learned that color blindness is in fact a recessive condition. So I'm going to put color blindness down here on the recessive B, and this top big B would be normal vision. Peter's maternal grandmother, I don't want to just race past this stuff. Those are important words. Maternal means like from your ma, back to Little House on the Prairie. Whereas if it was a paternal grandmother, that would be on your pa's side or your dad's side. Peter's maternal grandmother had normal color vision, and his maternal grandfather was colorblind. Peter's mother is whoa, I'm getting confused already. So I'd like to take a look at a family tree. So let's think about it that way. I've read through the story, and I've found that what we can sort of assume now is that Peter is way down here. There's Peter. And Peter has a grandmother. Well, here's Peter's mom and Peter's dad. But we care about the grandma on the mom's side. It says Peter's maternal grandmother had normal color vision. Well, I take a quick look over here at my legend, and I know that normal vision is brought about by the big B. So if the grandmother had normal vision, I'm going to say that grandma has at least one big B. I don't know about the other B yet, so I'm going to leave it blank. We'll fill it in probably soon. So she had normal color vision. I'm going to put a little check mark there. And his maternal grandfather was colorblind. So I come over to the grandfather here and say colorblind, as that tells us, is a little b, brought about by X little b. Peter's mother now is colorblind. We can check all of those things off. We're done with that. But Peter's mother is colorblind. So we come back down to here, find Peter's mom. There she is. And she is, as it says, color blind. We can read up there. Well, colorblind is, again, recessive. I can see up here. So that means she must have a little b and a little b. It's the only way. If she would have a big B, then of course she would be normal. But what does this show me? If Peter's mom has X little b, that means she was able to get an x little b from grandpa and an x little b from grandma? Well, we can see that this x little b would have been passed down to mom, but now I guess she needs to have another x little b transferring from grandma down to her. So grandma actually is x big B, x little b. Done. Peter's father has normal color vision. So check your legend again, and that is a x big B. Well, if this is the case, can we forecast and predict what Peter will actually have? Peter will receive the Y from Dad. And that means that he will get his X from Mom. Since Mom only has X little b's to offer, either that one or that one, it really doesn't matter, because Peter will receive an X little b. If that's the case, Peter clearly is color blind. So let's jump up and look at all of our questions and see if we can answer those. So let's move all of this out of the way and see what we get in our questions. What are the genotypes of all the individuals described? Well, you know what? We can just take a look down at our map, at our family tree, something that tomorrow we'll be calling a pedigree, and find the answers for 3A. 3B, what type of color vision does Peter have? Again, we realize that Peter is colorblind based on his genotype. What type of color vision do his sisters have? Well, I didn't know about a sister. Well, let's go ahead and add a sister in. Let's pretend that Mom and Dad actually had another kid. We're going to have her be XX. Again, receiving an X from Dad, which is an X big B, and an X from Mom, which is an X little b. And that shows me that his sisters are going to be X big B, X little b, again, X big B wins, and those girls are going to be normal vision. Well, then let's take a quick glance down. Whoa, what is going on? Let me pause and fix this. All right, I think I've come close. If Peter were to marry a woman who is genotypically the same as his sister Lisa, there's Lisa down here, what type of color vision would be expected in their children? So simply, I need to take somebody like Peter and somebody like Lisa and put them into a Punnett square. So let's go ahead and do that, and I've started us right here doing something just like that. So let me pause one more time. All right, I think I'm finally good here. Let's take somebody like Peter and somebody like his sister and mate them together here in the square. We clearly have X little b that will separate away from the Y in meiosis, so that there are two different possible kind of sperm here. And we would see that in the girl, meiosis would yield two different kinds of eggs, the X big B egg and the X little b egg. And finally, to bring them together, we can see we've got an X big B, X little b, X big B, Y, X little b, and an X little b, Y. The girls are normal and colorblind. And the boys are half normal and half colorblind as well. Hope that helps.